Memory forensics. Hello, this lecture is on memory forensics. Let's take a look at the purpose of memory forensics. Why are we doing memory forensics? There may be many reasons, but we have summarized as follows: process behavior detection, network connection information, user behavior, decryption, unpacking, decoded data acquisition, password and cryptographic key acquisition. All this information is stored in memory. We use that data very easily from the operating system. Nowadays, fileless malware is a trend. Fileless malware is a malware that does not store files on your hard disk. Because fileless malware is not stored on the hard disk, even if you analyze the hard disk, it is not easy to identify the reality. But the memory is different. Since memory is where all the programs that are running are present, you can also find fileless traces of malicious code. Network connection information is also stored in memory. The netstat command we commonly enter is also a command that shows us the results stored in memory. User activity can also be found on the hard disk, but since the data stored on the hard disk is also uploaded to memory, user behavior can easily be found in memory. When data is transformed into a format that we cannot recognize, such as decoded data, unpacked data, etc., it is detransformed and stored in memory. We can acquire deformation-free data through memory forensics. We'll take a look at how long the data is in memory. The graph here is a test of how much data remains in memory in Red Hat 6.1 and Solaris 8. The test measured the hash value on a page-by-page basis in memory to see if the hash value changed. As a result of observing memory for a specified period of time in each operating system, we can see that quite a lot of data is unchanged. The result is that we can often refute the proposition that data in memory is easily deleted or changed. For this reason, the importance and effectiveness of memory forensics is more significant. A memory forensic target can be physical memory, a page file stored on the hard disk, or a hibernation file. A page file is a file created by swapping page data from memory to a hard disk. It's the data that once was in memory. The hibernation file is a file that is created in sleep mode. When the notebook or PC goes into sleep mode, the computer does nothing. And when we shake the mouse, the state is restored and we can use the computer in its previous state, which is when hibernation file is used to recover the state. Let's check the physical memory size in Windows. First, run the command prompt window, type the systeminfo command, and use the pipeline and findstr command to search for the word memory. The systeminfo command is a command that allows you to check various information in the system. And the pipeline is an operator that passes the output of the left command to the input of the left command. The findstr command is used to search for strings in Windows. On Linux, this is a command similar to grep. Did you check? The resulting memory capacity is the amount of physical memory on your computer that you are currently using. Note that on x86 architectures, that is, computers with 32-bit architecture, the recognizable physical memory size is 4 GB. This is because the address range that can be represented in a 32-bit architecture is 4 GB. Let's look at virtual memory this time. We just looked at physical memory. However, physical memory has major drawbacks. It is a big disadvantage that you have insufficient capacity than the exponentially increasing amount of data. Storage media such as hard disk and USB are getting bigger in size these days, but memory is not. There are a lot of files that are well over 1 GB nowadays. However, the computer must load in memory the data that it needs to run or use. However, there are times when I use several files at the same time without using only one file. Virtual memory has been created to solve this problem. The concept is that each process gives up as much physical memory space as it can use. So, where are these spaces? Physical memory? No, these spaces exist on the hard disk. The principle of setting a certain area of the hard disk as a virtual memory space and deceiving it as physical memory. The computer then uploads the data in the virtual memory space to physical memory at the appropriate time to perform the actual data processing. If you look at the picture, you can see that each process is allocated memory space equal to the size of physical memory. This virtual or physical memory space is divided into a user area and a kernel area. The user area is the space in which the data used by the user is stored, and the kernel area is the space in which the operating system uses the data. I have drawn a bit more detail on the user space of the memory space for your reference. Beyond virtual memory, other technologies can also address the scarcity of physical memory. A technique called physical address extension is a logical way to make a 32-bit architecture to a 36-bit architecture. It is a technology that can be supported by the operating system and supported only by the mainboard, so it's not commonly used these days. Now, let's look at how the data is stored in memory. The memory seems to store data indiscriminately, but it is not. Data is stored in a structured way. The most important factor when storing data is the process that uses the data. Based on the Windows operating system, processes are stored in memory as eProcess. The eProcess structure is a very important structure that includes relationships with other processes, data management used by the processes, and additional information about the process. The eProcess structure has a number of items, but we have summarized in the lecture material what we need to do when it comes to memory forensics. Create time and exit time are very important information for tracking process usage information, and the unique process LD entry is also very important because all processes are given a unique ID. Please also take a look at other information. I told you before that the eProcess structure is important, right? There is also information about relationship with other process. Among the information in eProcess, there is an active process links item, which indicates the relationship with other processes. Usually, the information that the item has is called a circular double linked list. Each process has a circular structure. For example, if you have a single process, it has information about the processes that existed before it and information about processes that exist behind it. Each process is linked in this way, which eventually becomes a circle. This is called a circular structure. I have drawn a circular double-linked list structure. Initially, we use the PSActive process head to find the first process. From that first process to the next, if you continue to find it this way, you will see PSActive process head again when you find the next process in the final process. This is the end of the circle. We just studied that the processes in memory exist in the way we just stated. But do the attackers not know this? Attackers may know better than we do, and we've done a lot of research to bypass them and make sure that the malware they create does not appear in the process list. The results are a number of techniques that are currently shown in the lecture materials. The most common and often used technique here is DKOM. DKOM technology is a technique to exclude processes created from circular double-linked lists. How to exclude is simple. You can make your information skip ahead of the process you created. And hidden processes store their information because they cause errors in the operating system if they do not have any information. Your process is excluded from the circular double-linked list structure. So if you use the circular double-linked list to identify the process list, you cannot tell that the process is hidden. So, how do I find hidden processes in memory using DKOM? There are many researches on how to do this. However, it does not fit the difficulty of the current lecture. So far, I've talked about memory and memory forensics in general. So, we need to collect memory data for memory forensics. How do we collect memory data? In this chapter, we will look at memory data collection. There are many ways to collect memory, but there are methods using hardware and software. And there are crash dump and power-saving mode dump using operating system function. This is also a way to collect software using large categories. I'll show you a little unusual cold booting method and how to collect the memory data of a virtual machine that is inevitable these days. First, let's see how to dump using hardware. The hardware method is a method of collecting memory data by directly accessing memory using specially designed hardware. Hardware equipment is called Tribble. This equipment is based on PCI interface. The advantage of Tribble equipment is that it is fast and ensures maximum data integrity. A fatal drawback, however, is that it must be installed on your computer in advance. If you install a Tribble device to collect memory data and reboot your PC, all the data and memory will be lost, and the memory data collection will be meaningless. Therefore, there is a disadvantage that it must be attached to the computer in advance. Next is the latest Capture Guard device. Like Tribble, the device is divided into PCI-based devices and Express Card-based devices. PCI-based equipment must be pre-fitted like Tribble. However, Express Card-based devices do not have to be pre-installed. However, there is a disadvantage that an Express Card must be supported in the memory data collection target. There is a way to do a memory dump using the FireWire port. FireWire is a popular port on Mac series PCs. With this port, memory data can be collected via DMA without going through the CPU. However, there is a disadvantage that the port is not common and memory data can be collected only for a specific target. There are many ways to acquire memory using hardware. This time, let's look at how to collect using software. The method using the software basically requires access to the memory through the operating system, so the administrator privilege of the operating system is required, and it's slower than hardware. This is a disadvantage, but the biggest advantage is that it can be easily used at any time, so in many cases, memory data collection is done by software. Let's start with DD. The DD tool is used to copy a lot of data such as disks as well as memory. It was originally created as a tool for Unix, but now exists for Windows purposes. The DD tool can copy accessible memory data in bytes or blocks, and the copy unit can be specified by the user. Please refer to lecture materials for examples. The Dumpit tool is a tool dedicated to memory data collection. It is a free tool developed by a company called Moonsouls. It supports most Windows versions and supports both 32-bit and 64-bit architectures. The Memrise tool is a tool created by the Mandiant Company. The Mandiant Company is famous for its analysis of infringement. The Memrise tool is a tool created to collect memory for analysis when analyzing an infestation incident. This tool is available free of charge to anyone. Please refer to the lecture materials for the download path. This is FastDump Pro, a commercial memory data collection tool developed by a company called HB Gary. Although the free version exists, it does not support 64-bit architecture operating system and some operating systems. The tool is lightweight and fast. The RAM Capturer tool developed by Belka Soft is a graphical user interface GUI tool that is slightly different from other tools. Usually, the Memory Data Collection tool supports the command line interface CLI method to minimize memory corruption. The RAM Capturer tool dumps memory in the kernel area. If you dump memory in the kernel area, memory data collection is performed with higher authority so you can proceed with memory data collection without being disturbed by memory protection bypasses and anti-memory dumps. This time, I will introduce a crash dump. A crash dump is a method used to save the memory status of an error when an error occurs in the operating system to a file to resolve future error. It does not require any additional software and is a method of acquiring physical memory with the Windows operating system itself. Therefore, you can collect cleaner memory data than collect memory data using a separate software tool. You can also perform memory forensics by collecting memory data with a crash dump, although the purpose is different, but the method is the same. Crash dumps do not collect the entire memory by default. It only makes the areas that are expected to have an error to a file. Therefore, data collected using a crash dump may not contain the data we want. You can set up a crash dump by accessing the path mentioned in the lecture material in the Computer Properties window. The types of crash dumps are divided into kernel memory dumps, small memory dumps, and full memory dumps. In Windows 7, the full memory dump option disappears and you will not be able to do a full memory data collection with a crash dump. And for Windows 8, the automatic memory dump option has been added. The automatic memory dump option is an option to automatically dump the memory and save it to a file when an error occurs in the operating system. By default, a crash dump can only be performed if an error occurs in the operating system. However, if you modify the Windows registry, you can use a shortcut to run a crash dump. Please refer to the lecture materials for registry modification method and registry data. You can collect data from physical memory by editing the registry like shown in the lecture and running a crash dump using shortcut keys. However, you need to reboot your computer after making the appropriate settings. Therefore, the corresponding settings must be set in advance. Sleep mode is a feature supported by the operating system. By default, portable devices such as laptops use sleep mode to reduce battery drain. I also use the desktop, but it is not the default. All data in the memory is saved as a file in the power save mode. When the sleep mode is released, the memory file that was saved as a file is reloaded into memory. Because it is an operating system function, no additional program is required. The data stored in the file is the area in use in physical memory. The memory data resides in the hyperfill.sys file under the system drive in the sleep mode. This time, I will introduce cold boot. The cold boot method is a method of collecting memory data from a terminated system. Before the cold boot study, it was clear that the memory of the shutdown system would disappear momentarily. However, after the cold boot method was studied, the orthodoxy was discredited. The cold boot study proved that data is preserved by rapidly freezing the memory of a system that has just ended. So, if you want to collect the memory data of the terminated system, you can collect by freezing the memory of the system just shut down and reading it with a specially designed reader. The picture you are seeing now shows you how to use the cold boot method to obtain the password required to unlock your smartphone from your smartphone memory. Of course, your smartphone is shut down. Finally, I will explain how to collect memory in a virtual machine. Nowadays, there are many users who use virtual machines in the cloud environment and programs such as VMware and VirtualBox. In particular, the client or PC provided to users in a cloud environment is a virtual environment. If you collect memory data in such an environment, you do not need a separate tool. You can take advantage of the features of the virtual machine software. There is a function of virtual machine software called pause. The pause function prevents the virtual machine from running for a while. The function will be used to pause for a while, and when it restarts, it will restore the previous state, so the memory will be saved as a file. We can copy this file and do a memory forensic analysis. So far, we've looked at memory data collection. In reality, we use memory data collection method using software more than hardware-type memory data collection method. It is recommended that the collected memory data be stored in an external storage device as much as possible. Physical memory varies in size depending on the client or server. The size is different, and if you store large physical memory locally, the deleted data will be overwritten with the physical memory, and the deleted data may not be recovered. If the external storage device does not have enough space to store the physical memory or the file system is not supported, you may consider using the data partition of the analyzed PC.